Hello. So yeah, I believe that this is the perfect talk for you to sleep. So if you do so, don't worry about it. I will wake you up when all the most important bits of the talks are appearing on the screen. So I will maybe shout something, and then you will open your eyes and you will learn something. You know, micro-learning, like if this was TikTok or something like that. So yeah, this is a little bit funny because we are in a Python conference, and I'm here to talk to you about other languages. The main reason for this is that I believe that Python is at the level it is currently at the moment because of other languages. Not only because it's written in C, but because other languages make Python really shine. So my name is Cristián. You can follow me on social media there. The handle will be down. If you have any questions, any requests, just let me know. I know some people like to take notes sometimes or write important things. I don't like that. I prefer people to pay attention to the slides. So the slides are there. You can go there and do the spoiler of all the things that I will talk, but they will be there. If you have any questions later on, you can always ask me about the URL. I will be around tomorrow as well. So you can check that and get all the links, all the videos, all the details of the slides. Okay, first question. How many languages do you know? Of course, programming languages. So besides Python, how many people here know other 2 languages besides Python? What about 5 languages more? I will not ask you, don't worry. I trust your gut. So more than 8 languages besides Python. Oh, no, brave. Okay, yeah, in another conference I have 2. So this is, you're lowering the bar. So I think that most of the time when I talk about C++ or C or everything, usually people tell me Python is simple. And this is something that I firmly believe that it's not a simple language. So let's do a little exercise so you can wake up. So how do you, maybe most of you, create a list here? Most probably like this, right? If you have to maybe a set of characters. If you're a little bit smarter, you said, I can use the constructor because a string is enterable, right? You can do that. But you can also do this. And this is valid Python code. And you can still, so imagine showing this to someone learning Python. They will be a little bit confused. Let's do something more applied, use case scenario. Checking the number, if a number is a power of 2, if you remember your math classes, if you had some, you will remember some properties like that. So you can do this like this, right? You can get this equivalence and check if something is a power of 2. You can also do this. If you like golfing, that's another topic, but if you like golfing, you are familiar with this. You can go down to this. I remember I submitted this answer in some golfing tournament and it was like, okay, nobody can beat me. And they beat me with that, 1 character less. That is valid Python code. I'm not inventing things, not doing weird things. So if you have questions, you can ask me later. Lookup table, again, you have a simple lookup table. You can be a smart person and say, oh, I will create a dictionary. You can be even smarter and say, I will create a tuple and I will just access that. Or you cannot be not so smart maybe and do it in binary, then change it into a number, and then do a bit shift operator in order to get the values of this. This is valid Python code. So see, language can be easy and can be difficult. I really don't want, at least for everyone here that is not familiar with C++, Zig, or Rust, not to be scared because it's not as simple as Python. So are we, as Python developers, using other languages? I will try to rush to this section, so don't worry about it, because I want you to get to the good stuff. If you know NumPy, yes, we are using other languages. You see there C, C++, well, Python is not another language, but some people might say. Fortran, there is still some little bit of Fortran there. Pandas as well, because it's based on NumPy, so you'll still have some C reminders there. Scikit-learn, you start to see a different tendency there, a little bit more of Python, but not so much C. And then we go to the big modules currently used in machine learning and data science, TensorFlow, with all this percentage of C++. Even with PyTorch, same idea, because we have a module under the hood that is written in C++, and they even have CUDA, as you know. So many languages going there. If you're familiar with new things or the new kids on the block, if you're using Rust already, you know that it's mostly written in Rust, and they have like a couple of files in order to create the wheels. So then the question arises, why we need to use other languages? I believe that there are like a couple of points that are quite important. It's a summary of why we use other languages. The first one is, in my opinion, is to get in touch with new technologies. Sometimes there are languages that are dependent of some new technologies or something that we want to get maybe in our companies or study universities or whatever. also being able to understand software, because when you learn more programming languages, you see, oh, this really resembles Java or C# or whatever. So you are able to understand the idea behind the languages and not only base your knowledge on the syntax. Another thing is reaching a new stack or platform. Maybe you saw a couple of versions ago in Python when they enable CPython to be able to compile to WebAssembly. So then you could discover a new platform and you can explore things, and there were new cool things announced like PyScript recently, and then you can do WebAssembly things now in Python. Not fully, but you can do something. And the other reason, of course, is that because Python is slow, as maybe you have heard many times with other people doing these super hardcore programming languages. So how many languages are there? Of course, we will not go to the whole list, but if you go to Wikipedia, read the exercise scrolling there, order by alphabetical order, and then you see like there are lots of languages. Of course, we don't need to learn them all. So let's go back to our main topic, Python. So let's understand Python. And even that question is super tricky, because then some of you will say, which Python? Python has many implementations. Maybe you know or kind of like understand like which of these, what does these logos mean? Maybe you're familiar with MicroPython, CircuitPython. Maybe you heard about the short life of Pigeon. Maybe you're familiar with Cinder, the Python fork that Instagram has and is running in the servers, PyPy, and so on and so forth. So there are many implementations of Python. So for this, I will try to focus only on CPython, which is what we call the standard implementation. I love this topic. I believe that it's a topic that is super interesting. Some people is super afraid of it, but this talk will not be a lot about CPython. If you're interested in this, I have given all the talks in case you want the same kind of page. You can find other interesting bits about it. So let's extend CPython, put in now the C, so make the exception, with other languages. The documentation, in my opinion, it's super useful, and it's clear. You need to read a couple of times because it's dense, but it's useful to understand how to create. So the building blocks for creating an extension in C, and now everyone will fall asleep, is only 4 things. So first, you need to use the C API that Python provides in order to create your function. Define the methods that you will use, the module that you will define, and also do the final initialization of everything. This sounds abstract, but don't worry, I got you covered. This is the simplest C extensions that I could ever think about it. There are a lot of things there related to C. It's only a new module that's called simple. Then there was one function called hello, and that function says hola PyCon Lithuania. Nothing else like that. It looks weird. I know if you try to understand all the bits there, but believe me, you can take this thing, put it in, and add some other things, like for a setup PY. Of course, you can do pyproject.toml, but setup PY, and then run a simple command, and you get your first package. You can take this, modify, do whatever function you have, and you can have your C extension-based Python module. So it's not so complicated. It's complicated when you start to study each part of the lines there, and all the why there is a parenthesis there or something like that. But it's approachable. I want you to really, at some point, to have the time to take this, try to compile it, and see if it works. And then there's an example there how to use it. So the syntax, as I said, can be scary. But for that, I think that it's better to understand how the syntax of other languages works. So now there's a section that I will try to give you a super brief introduction, because this is a short presentation of 3 languages, and I will try to go to a little bit faster so we can get to the final part. First one, C++, dear to my heart, one of the first programming languages that I learned before Python. If you know, it's an extension of C. It's not the same. Some people do C/C++. It's not the same. It's a different language. One of the things that the language shines is because you have low memory handling. It's super performant. It's used everywhere. The documentation is amazing, or not, I don't know. And but some people still believe that it's super weird. If you look there at the hello world, you will ask me what are those? Why you are using minus minus? What is code or end weird things? I know, but latest versions of things are really getting Pythonic, in my opinion. So, for example, the latest release of C++23, you can write your hello world like that. Sounds super familiar, right? I mean, you can just define a main and have a print hello world. So what about a comparison? This is a basic Python class that I hope everyone here is familiar with. It's just a rectangle. I put some there, some type hints, some of those, just to highlight what would be the equivalent in C++. If you look at this, looking at the Python implementation, C++ is not so strange. Of course, there are things like this public, there's, you can do the return in the same way that you are defining the thing, you can implement the method outside a class, but it's not so strange compared to what you have in the Python thing. I hope that it is for you to read there. Of course, with the other reference, you can see like, well, it kind of makes sense. So in a nutshell, you can see this is simple, of course, C++, and you can get it like right away from some Python code. So in summary, there is a really cool talk by last year's keynote by the creator of C++ that I recommended if it's your thing. And just a couple of points just for you to take home is super widely used. And if you learn C++ now, I promise you will still have a job in maybe 5 years. There is no pip equivalent. This is a pain point in C++. There are like many options, not as many as Python, but many options that none of those is the standard. The recent version has a similar syntax, and some features can be super complex, like templating or metaprogramming. Next language, Rust. So Rust, when they advertise in the super colorful website, is like they are super performance, reliable, and you can be productive with it. The code changed quite a lot there. You have these weird parameters and arguments, and you still need to compile everything. But it looks weird. There's not a typo in the exclamation mark there. It is like that because it's a special macro. How many people here know Rust or have written some Rust code? Cool. So you are super familiar with the hello world, at least I hope. Again, let's compare them. So I have two examples here. One is a simple one. I add some type hindrance to be more fair in the comparison. You define a list of integers, and then you do some operation, and you print the result. See, for the non-Rust people, I hope that this is not so crazy for you. I mean, there's like this YI32, what is this? But still, you kind of see like, oh, okay, so it's like a type hint that I need to put there, and the amount of items, and it's not so crazy different, of course. Again, we're the same class-related things, and we encounter our first issue. Oh, there's no classes in Rust. So yeah, it's not classes, it's completely fine. You can still manage to get your code that is based in object-oriented approach in Rust, because then you can extend the structures. And then you can see there you have a definition of a struct that really looks like a data class if you're like know that feature in Python. And then you do the implementation of that struct with the different modules. Again, I hope that this is as well, it is not super clear, but you can see and feel like, there are some like similarities in the languages, so maybe I can write that code and try to compile myself. Quick summary then, the memory management again, if you heard about it, like ownership and borrowing, it's essential to Rust to ensure safeness of the language. There is a super amazing tool called Cargo. If the Rust people, they will know it. I believe that is what every single language needs. It's super complete. The ecosystem, as you saw, maybe lately in news, Rust is getting everywhere. They managed to get some Rust code into the Linux kernel, some modules and stuff. But it's a language that is still evolving. There is a really cool talk as well that is like Rust for Python developers. That was in the Swiss Python Summit 2 years ago. I think that is still relevant. The API might be different because Rust changes this API quite often, but I recommend for you to do. Good. So now who here knows this language? I will not ask you a question, don't worry. Knows the language. Okay, cool. This is a super cool language. I think that, I mean, if you made me choose like now for just how the language is designed, I will go for Zig rather than Rust. Not saying that it's better because of whatever, because I don't know, the feeling that I got from the language, it was super interesting. And the logo is cooler, I don't know. And they have a little mascot. I didn't put it here. It's a little lizard. You can check it out later. So here's some Zig code for the people that has some nightmares still, maybe with other programming language that you need long screens to program. I will not say the name. Maybe you will get some flashbacks on the standard.io.get, standard out on writer or whatever. But I promise you, it's not as painful as you see there. It is only mainly because to make the abstraction and have a simpler print. You still have some imports on the top, as you can see, and you can compile as well. Another weird thing is that I am trying to print. So this is getting you like a summary of why the language is designed in that way. So they claim that the basis of the programming language is having no flow control and not hidden memory allocation. So everything will need to take care by you. There's no preprocessors that some people believe that is the poison of C++. Some people believe it's useful. So also no macros. And they have a really cool thing, which is a compile time statement that you can have code there, of course, will be like, have some lazy evaluation when you have your code. And has a built-in test framework. So people doing testing, I know sometimes can be painful, but this, again, you do some tests, and then you have your test inside. Everything is included. Python and Zig, again, a comparison, our friendly rectangle class that we saw before, but now in Zig. I know more lines of code, but still you can feel like compared to Rust also had like the definition of the struct, but then you can have the implementation within the definition of the struct, and then we just call the main there. I hope that is clear. Now you can analyze it like afterwards, but I believe that is clear. Again, summary, they claim to be faster and more secure than C. They integrate super easily with C libraries. I will show you an example right away. They have the built-in testing framework, the comp time magical box, and some of the things that I really love that it might be removed, it was that you had cross-compilation out of the box. So you had like one argument, and then you have your binary for Windows, Mac OS, Linux, and ARC64, other architectures as well. So if you work with cross-platform UI frameworks or like other type of frameworks, this is super helpful. Okay, now, cool. How we use it with Python. Then this is our example. I will go quickly to all these snippets in the last minutes I have. Maybe I will eat some questions time, but in order to show you more cool things. This is the previous example, nothing for you to remember. I will modify it to use the C++. The highlighted lines are the ones that think that I change. Nothing much change, and then you have your C++ application. And Zig, you can import the header, create some alias, define the function, define the methods, define the module, and put everything. So then you are thinking, oh, you create also this special script. So maybe you're thinking you need to write everything by hand. Well, the good answer is no, because there are a lot of binding generation. This can be yet another couple of talks, but let me just go really quick on it. So in C++, a binding generator would be something like this. This is a really popular one, PyBind11. You can add some little code at the bottom, do some magical compile and step, and then you get out of this C++ a Python module. Another thing that where I work with and something that I develop is like if you don't want to touch your source code, then you can specify some external XML file, do some CMake magic, and expose a Python module. And then you have PyO3. There's a talk, of course, after this afternoon. I believe PyO3 is amazing. The simplicity of the things that you need to present there in Rust in order to get the Python module is super, super, super easy and nice. And I do believe that now the popularity of Python, Rust-based modules in Python, it's because of how well PyO3 is put there. In Zig, do you remember that I showed you lots of code that you need to take care of? Well, also there is a binding generator here that simplifies quite a lot everything. Then you see the comp time special thing that we mentioned before. So quite simple as well. So you can have a simple Python extension. So what's the catch? Of course, extending Python with other languages, then you will need to take the other languages, the details, data types, there are some pointers, there's some memory management you can take it by hand, there's the guild now, that will be optional, but that's another story, and many other stories. So you need to take care of the details of your language as well. So I decided to do a real application. It's super open source. You can take a photo and be famous tomorrow and get like 1,000 stars in GitHub. I decided to take a function in Python that was really slow and widely known, glob. Everyone knows glob. Everyone knows that we have been like import glob, whatever. So we know glob, cool. I decided with my ignorance in Rust and PyO3 to write the simplest functions that I could do to resemble glob and to create a list of a string. This is really important, a list. I wanted a list of strings as a result. So I wrote this function. Maybe it's terrible for the people that know Rust, but I wrote this function. And I did a little benchmark. So for 1,000 directories and 1 million files, I did some tests with glob. So with non-recursive and recursive, this is the time in seconds. You can see that if I try to use path-leave glob, there I just put the recursive time because, as you can see, the penalty that I get in the non-recursive one is because I am building the list, because path-leave, as you know, returns an iterator, so it's not fair, the comparison. And then I have my super Rust implementation, when I get 85% improvement. And now you are thinking, this is it? This is the new RAF, the new Rust-based application, right? We get everything. So who here believes that Rust extensions are fast and that's why they are cool? Nobody believes that they're cool? Come on, don't be shy, yeah. I did the same in C++. In C++ is faster. Why? See? So my point here is not saying C++ is better, but my point here is the media wants to control us. No. That Rust is a cool language. It's a cool language, has many features, but do not buy into the because all Rust applications are super fast. I promise you, if you write the same thing in plain C, maybe you even get a better performance. Maybe it's not as simple, but then you can say, yeah, maybe the C++ implementation is super complicated. It's not. I just use a standard library because there's also something that you can do recursive directory iterators, and I create the list. It's super similar to what we have before. I got a better performance. Of course, this is one example in the whole world of examples that we have. I'm running out of time. And the last message that I wanted to let you know in this last minute is that this has a lot of today's importance in the discussion that we have out there. Some people still, I believe you are the best audience, so you are not really you don't fall into this kind of fight. Because I mean, for many people, sadly, and we need to teach those people, compile ones are faster. And we still get people that is like, oh my God, like what? This Rust application is faster than the Python one? This C++ application, Rust, of course. They are faster. There are some details, maybe you can find some edge cases where, oh, this is super close, but overall, in theory, you cannot kind of beat that so far with the runtime programming language. So the main point that I wanted to make that statement is because we see the popularity of Rust. Rust is a great language. I really enjoy. I'm doing now a real live application. I'm having super blast because the documentation is amazing. But I know a lot of people, at least maybe in my social bubble, that is still like going around thinking that this is the solution of all the problems. If you didn't get reference, don't worry, I will help you. I was talking about UV and Rye. So those are fantastic projects, but please, if you want to use them because you like Rust, because you like what their approach they are having, but not because it's faster. Because you know the argument of being faster, it can be done in any other languages. I do believe, and I trust Rye will have more potential than UV, but that's only my opinion. But this is the main message of this thing. So should we rewrite everything in Rust? I think that is the wrong question that we need to ask. Should we enable more people to be knowledgeable about? Yes. We need to have people being aware that writing something in C++ or Rust, I'm almost finished, in C++ or Rust or C will be faster than Python. It will be like that. It's completely fine. But if you like the language, do it. But don't do it because they claim it's 1 million times faster or something. You can do it in another language as well. And if that's your thing, you can do it, of course, use it as well. So is extending Python the only potential? Not. I will leave you with a couple of drops of information here. Please read that not only speed is the important thing here, there's the per interpret GIL changes that were coming into 3.12. Maybe if you heard about also making the global interpreter log optional, the faster CPython initiative that is bringing Python faster and faster, the JIT compiler that we have in 3.13 if you haven't tested out. And I believe that extending Python with other languages, of course, generates discussions, keeps the community active, includes other communities, which is one of the most important aspects, so we can have a greater Python language. So yeah, with that, thank you very much. I hope you learned something, and if you have any questions, you can reach me out afterwards. Thank you.
We still have time, a few minutes for the questions, and we have one question in the Discord chat. So the question goes...
what is the username? Is it like some random letters and an...
No, it's Pol. It's like Polus. Okay. Yeah. So can popular non-Python libraries be binding generated to Python? Are there any limitations for bigger libraries?
No. For example, I work in maybe some of you know the Qt framework, Qt framework. So that's a huge C++ framework. I don't call it library, it's a framework because so many files, and that's huge, and then we managed to expose it easily to Python via PySite with the Shiboken generator that I showed you before, so it is possible. It's difficult sometimes, but it is possible, so I believe that there is no many limitations. And don't ask me about templates, because templates are limitations, but yeah.
One more question.
So most of the examples you showed us, basically bindings rely on C API of the Python, right?
Yes.
So isn't the issue of the Python that C API is still considered unstable? And there were some talks like splitting some part of that C API to make it more stable and like minimalistic, etc. And I believe that's like flaw of Python, like not considering the C API as a decent API. For example, comparing to Lua.
Oh, Lua user, yeah. Who else knows Lua? Ah, okay, Lua rules. So yeah, I believe that the Python being written in C is a pain and a bless at the same time, because at the moment, because it's written in C, it's because to glue it with so many other languages. Most of them implement for FFI, for example, you can easily get around. I also work closely with the limited API, which is a Python, maybe this is what you were talking about. And this, yes, it's something that the problematic bit here is that not many projects use it. So as not many projects using it, there is difficult to find the flaws of it. So random project will say, hey, this doesn't work. Oh, nobody tried it before. So in this project that I work, for example, we use it, and we noticed that I think that we are the largest project using the limited API, so we generate 1 wheel per platform, which is like, as a PyPI maintainer, it's painful to see all these projects that generate 1,000 wheels for all the Python versions and architecture. So there is a lot of work going on at the moment. There are initiatives like HPy, maybe you heard about it. They claim to be the solution for it. So let's see. But I believe that they are aware of it. Now in the PyCon US, for example, there will be, I think, some discussions about the stable API, how it can be pushed forward to be a more stable and functional API. So yeah, but yeah, I believe that it has two sides of the questions.
Okay, thank you, Cristián. Thank you.